On today's episode of Inside Startup Investing, you are going to be hearing from Alec Shkolnik, who's the co-founder and CEO of LiquidPiston. I first met Alec probably almost 5 years ago now, and they've been at it ever since, making progress every year, continuing to raise capital, and really growing the business. The biggest thing that I think you're going to hear in this episode that stuck out to me is just one, how hard it is what they're doing. So they are literally creating a new type of internal combustion engine that is far superior and more efficient to any combustion engine we've really ever used in vehicles and military equipment, so on and so forth. It's a really innovative technology that came out of several MIT graduates, and they've been at it for years, and it's finally starting to pay off. Just to give you a sense, I don't think people realize sometimes how hard it can be to start up, but these folks over the past many, many years had raised about $30 million in grants and actual revenue sources from the military, but it's really hard to get funding from the military, right? You have to prove a lot of things to convince the military to work with you. And in the last couple of months alone, they've signed over $35 million worth of contracts. So when we talk about progress and that compounding effect of building a startup and seeing the progress come together, sometimes it takes a long time to suddenly see those overnight successes, right? You may have heard of things like the 10-year overnight success. Well, I think these guys are kind of on that path, and that's what so excites me about the business, is they have put in years and years of R&D, hard work, grinding it out, doing these grants with the military, and now they're starting to see those inflection points where they're really starting to grow the business. So really interesting story. Always great to see a team that's fighting through and making progress year over year over year. And it's also just a really fascinating story that I think is worth listening into. So with that, let's kick it off. Always like to start with, tell us a little bit about yourself, your background, and then if we get the one-liner on LiquidPiston, that would be great.
Absolutely. So I'm Alec Shkolnik. I'm the co-founder and CEO here at LiquidPiston. I have kind of a technical background with degrees in neuroscience and computer science and math. I did my PhD at MIT in artificial intelligence with a focus on motion planning. So really, modeling and optimization. And you might wonder what on earth any of that has to do with combustion engines. I like math. I like optimization. And when I was a PhD student, I was helping my father with some of his ideas. So my father, Nick, is a PhD in physics. He actually immigrated here from the Ukraine back in the 70s. And he's a physicist by training, and in practice, he was really like an innovation consultant. So he was always bothered by the inefficiency of today's engines, wondering, why does your car only convert like 15% of the energy and fuel into useful mechanical work? From a physics perspective, why can't we do better than that? And when we really kind of like look at the math and the fundamentals of how engines operate, we see that there is a lot of room for improvement there. Right. So we went back to really the fundamentals and innovated there. We developed a new kind of thermodynamic cycle, something that hasn't changed in over 150 years. And we embody that with a new kind of engine. It's a rotary engine that we call the X engine. And, the takeaway is this is a very simple device. It's about 5 to 10 times smaller and lighter than today's piston diesel engines that everybody's familiar with. It's also 30% more efficient with the new thermodynamic cycle. So the military has taken a keen interest in this technology. They have helped fund it. We've had the opportunity now to work with DARPA and the Army and Air Force. And actually, since that first raise that you mentioned, we've signed we've signed $65 million in contracts with the U.S. DoD since that first raise.
Let's talk about those contracts a little bit. How do those work? Have you already kind of run through all of those contracts, or are you working through them in the years to come?
Yeah, great question. So we started working with DARPA, which is the Defense Advanced Research Project Agency. They're kind of famous for inventing things like the internet, GPS technology like we know it, self-driving cars. So they really push forward technologies, stuff that obviously can benefit the warfighter, but a lot of their technologies end up spilling into the commercial sector. So we worked on 3 projects with them, and then we sort of graduated from DARPA and began more work with the Army and the Air Force. It's kind of unique that we have so much interest from such a diverse set of players in the DoD. The DoD is really cool because they are a end customer, and also they can help to fund the development, right? So they can do both pieces. Within the DoD, just kind of everywhere you look, they have needs for more power and more energy, and the solutions that they have available today, they're not adequate for what they're trying to do and what they need to do in order to sustain defense. So it's just we're solving a really immediate and painful problem that they have. And with regards to the contracts, most of the contracts, about $55 million has come in the last 2 years. And we just announced a new contract. 35 million of that 55 was just signed a few weeks ago. And that'll be funding us through 2026. So basically we turned profitable starting in 2022, and we expect to be pretty close to break even. We're not trying to make a large profit on these contracts, but they are helping to fund, a significant portion of the development, at least for the DoD applications through 2026.
And those DoD applications, is that revenue or is that equity investments?
No, the DoD doesn't do equity investments. So we are working with the venture arm of the Air Force, but this is a contract in the end. So really it's, it's a contract with milestones. We have kind of monthly deliverables. And so far, in executing all these programs, we have 100% success rate in fulfilling our milestones. So, that the government has increasing confidence that we can deliver what we say we're going to deliver. And that's why each set of contracts we've had has been greater than the last, right? So, yeah.
Now, you mentioned that you're solving an immediate need and pain point that they have. Could you talk about what that immediate need is, what the pain point really is?
Yeah, if you look at the power and energy solutions that we have today, right, we've got gasoline engines, which are really inefficient. And also for the DoD and within aerospace, this is the single largest consumer of oil on the planet, right? The U.S. Department of Defense is the single largest consumer. Now, they have a mandate. They would like everything to run on one fuel for logistical purposes. Fuel and water, the logistics of delivering fuel and water to the front line represented about half of our casualties in Iraq and Afghanistan. And we see this in all sorts of conflicts. You see it in Ukraine, for example. But, fuel makes a really good target, right? And it's really hard. It can take up to 100 gallons to push 1 gallon to the front line. So it's really expensive, but it's also measured in lives, literally half our casualties. So anything we can do to reduce the logistical burden, to reduce the size and weight of our generators, to provide more power to our vehicles, to provide additional auxiliary power. I'll give you just a couple of examples. We were working with the howitzer group in the Army, and these are basically very large muskets, right? This is a technology that's like hundreds of years old, but increasingly they need more and more computational power for very sophisticated control algorithms that help to put the ballistic right where it needs to go. And they don't have power for that, right? And they don't want to carry a diesel generator because it's too big, it's too heavy. It could displace up to a third of the ammunition that they're able to carry, and it's noisy and whiny. So right now they just idle their trucks, and they're siphoning just a little bit of power to idle their trucks. They're burning about 2 gallons of fuel per hour every hour, and it's just not it's not a win-win for anybody, right? These trucks are noisy. They're burning a lot of fuel. So they would like to have a small portable genset just to provide power for the gun. That's one example of a contract that we worked on with the Army. And literally every stone we look at in the Army, every application that you look at, they need more power. And, especially things that fly, like drones. And you look at what's happening in the conflict in Ukraine, they're calling it the first drone war, right? This is what warfare is going to be looking like in the future, or fortunately or not, it's drones against drones. And power and energy is fundamentally limiting to things that fly, right? If you have a larger engine, you can carry less fuel or you can carry less payload, and that's a big problem for them.
Now, the technology that you have, can you put these engines in nearly anything? Can you put in a generator and a vehicle and a drone as well?
Yeah, it's a scalable technology. So much like a piston engine, you can have like a multi-cylinder piston. You can scale the bore and the length of the stroke. We have similar knobs for our technology, and it's equally versatile as a piston. So all of the knobs that work for piston engines, you can go carbureted all the way to common rail direct injection, right? We can do the same with our engine. We literally had a YouTuber come to our shop a month ago, and he converted our engine with a carburetor to run on vodka, of all things. Okay, and on the other extreme, we're running common rail diesel in our rotary. So we can run naturally aspirated, supercharged. We can scale the rotor up. We can do multiple rotors. So really, we can serve engine markets between 5 horsepower up to 1,000 horsepower. We're starting with defense applications and aerospace applications. For a startup company, this is a good place for us to start, because number one, there's a customer that's willing to help pay for development, right? And we're kind of following the money here. But also it's a low volume application and emissions exempt. And both of that, low volume means it's high price or relatively price insensitive. So it's an easier market for us to penetrate into compared to, for example, the automotive market. I get questions about this all the time. Why don't we just go straight to the automotive market? Well, it can take 20 years to penetrate the automotive market with a good technology. So we are very purposefully kind of targeting a different niche application. But you're 100% correct that the technology can be scaled and adapted for pretty much any place where you use engines today, and even small turbines.
Yeah, there's certainly exceptionally high barriers to entry in terms of actually being able to get into the right products and be in market in something like what you're doing. I'd love to understand a little bit more. For instance, if you have this new kind of combustible engine that's more efficient, if it means going into a drone, or it means going into a military vehicle, or even a generator, I mean, there are producers of the generators and the drones and the vehicles. So is the military now going to them and saying, hey, we're working with these more efficient engine creators, you need to input their engine into your solution? How does it actually work where your engine gets placed into items that they're using?
Yeah, great questions. So let's talk about both directions here. In the drone area, there's simply put, there are no heavy fuel solutions in the power classes that are of interest. So right now, the most widely fielded drone by the U.S. Army is called the Shadow UAV, and it's produced by Textron. Currently, it also uses a Wankel rotary engine, ironically, but it's not able to run on heavy fuel. So that's a key challenge. Right now, they have to carry 2 fuels to the front line, and they're mandating a single fuel, but then they make an exemption because there simply is no technology that's able to provide heavy fuel capability. So for them, it's a game changer. And as soon as that technology becomes available, I think that they're going to then mandate it. So they're not going to necessarily mandate that everybody puts in a liquid piston engine, but as soon as they mandate that everything now for real has to be heavy fueled, including all of our drones, there's going to be very little choice out there other than our technology. So that's on one hand. On the other hand, we literally, a lot of folks in the government are putting us directly in touch with a lot of these integrators. And, our business model, we are not going to be a high volume producer of engines necessarily. We might produce engines in low volumes initially for a few initial applications. And drones is a good one where, you might make a few hundred per year. But really, we're a business-to-business company. We're an IP company. We have 82 patents on the technology that are either granted or pending. And we provide engineering services. So we figure out what is the best engine and power solution, right? A lot of what we're doing is hybrid electric. And it's really adapting the technology for specific use cases. And our customers include the DoD, but now they're also including commercial entities. So these defense integrators, for example, or non-defense integrators, but aircraft manufacturers might pay us to develop a power solution for their application. And then the idea would be ultimately to license the technology into production to serve them.
Business model wise, just to make sure we fully understand, can you talk about the handful of ways in which you can make money and commercialize your technology?
Yeah, there are several prongs. So right now we're in the phase of kind of pretty much most of our revenue comes from government contracts. So these are engineering services oriented for kind of research and development for government purposes. And we're using this and kind of reinvesting every dollar of contract revenue that we get is basically helping to develop the technology and demonstrate it in various use cases for the DoD. Moving past that, we move into engineering services for commercial companies. So a lot of people don't know this, but when Ford, for example, or pretty much any of the automotive companies come out with a new engine, they hire one of a handful of consultancies that handle most of the development work of an engine, or they might split it 50-50. But FEV, IAV, Ricardo, AVL, those four companies probably do 90% of the automotive piston engine development work. And these are billion-dollar companies, and all they do is provide engineering services. And it's expensive and time-consuming to develop a new engine. So that's our second revenue prong, is providing these engineering services, and we can put teams of engineers around different applications and have it funded by the customer. And then the third piece of this is licensing. So once the technology is fully fielded and we can transition it to higher volume producers, there's a lot of companies out there that are really good at making things, including engines. They already have the manufacturing, the quality controls, the sales, the service, the distribution channels, all of these pieces that we as a small innovative company, we don't have those pieces necessarily. So you can think of us like the technology arm, and those incumbents are the players that kind of have those really expensive capitally expensive pieces. But what we're left with is licensing, which is a very high profit business model. So those are kind of the three revenue streams. And the cool thing about that is that we don't have to, we don't have to have a high volume fielded application to be profitable. In fact, we reached profitability already last year with this business model.
There is within kind of the military segment. And then as you think beyond that, what is the next expansionary category? Where do you go from there? And help us understand just how big an opportunity could exist out there for that.
So the military, just to give you a sense, we're talking initially about drones and also portable generators, right? And right now the Army has about 30,000 small gensets below 5 kilowatts that are fielded, that are really outdated, okay? And when we look at the history of contracts around generators, a single contract can be worth about $100 to $400 million. So that might be relatively small for a large incumbent, but for a young company like ours, it's a sizable contract, and it would be a multi-year contract, and that's for each power class, you would get something like that. So that's that would be a successful kind of transition into something like the Army. Now, moving past that, it's a $400 billion market for internal combustion engines. I'm not even counting when you go a little bit bigger to include, hybrid propulsion systems and generators, which we also are very active in that area. And then we can go even a little bit broader into things like APUs, auxiliary power units. We're finding today, and just for the viewers out there, when you have larger vehicles, a lot of them have some type of engine or a large turbine for propulsion, but then they will also have a secondary engine, like a smaller engine, that's used for non-propulsive functions. If you look at an aircraft, for example, out the tail cone, there's a little engine sitting in the tail cone, and that provides power to start the main engines, and it provides power for air conditioning and electricity when you're sitting on the ground, for example. Helicopters have those, tanks have those, even like police vehicles will often, a lot of these vehicles that sit for a long time and idle, but they need power while they idle, or hotel comfort, will have these secondary engines. So, that's an area that really excites me. It's not something that I've really paid a lot of attention to before, but these are applications that total up to hundreds of millions of dollars. And so, it's a $400 billion market for engines overall. About $300 billion is in the automotive and trucking space, which we can get to eventually. But there's $100 billion of other markets out there. That's just enormous and kind of mind-blowing. Everybody thinks that, with electrification, that all of this is going away, but in reality, that's not quite the case, right? First of all, with the expansion of the middle class in India and China, we're actually still seeing that the internal combustion engine market is still growing right now. And beyond that, our technology in particular is really good at coupling with electrification. So if you think about like electrifying a vehicle, for example, the greatest feature of a electric car is regenerative braking, right? It takes a lot of energy to accelerate your vehicle. And when you hit the brakes, if you throw all that away with heat, which is what standard brakes do, that's incredibly wasteful in terms of energy. So instead, if you use the motor in reverse, it becomes a generator, and it can put that energy back into a battery. That's great. That's a win-win for everybody. But the flip side of that is if we try to use the battery for everything, right? Something like a Tesla carries a 1,200-pound battery. It requires enormous resources to manufacture and produce. It has this just giant environmental footprint that we've been kind of neglecting. And also the government has kind of labeled the MPGE, right, the mile per gallon equivalent, but they only look at the energy starting at the battery and then going into the wheels. They completely neglect how the electrons got into the battery. And the reality is that we burn a lot of fossil fuel at a power plant, and then that it gets distributed, through our networks. But we just don't have enough of these power generation plants, and the distribution networks are too fragile, right? 4 gas stations, if you look at the energy that flows through 4 gas stations per unit of time, that's power. 4 gas stations would have to be replaced with a small nuclear power plant to deliver the same amount of power per unit of time. If you just want to try to switch to electric vehicles overnight, it would be really, really challenging. So think of us like a replacement for a really big battery. Instead of a really big battery, we can use a small battery. You still get all the benefits of electric. Maybe you get 30, 40 miles of range. So even, typically you're going to be driving electrically. But the cases where you need to go more than 30 miles, you've got the onboard generator. It's efficient. It can use a variety of fuels, including sustainable fuels, which can be very low carbon or even zero carbon. For example, hydrogen. The main output of hydrogen would be water, and that is something that we've demonstrated the ability to run on. So we can complement the battery and really help to accelerate the electrification of vehicles. I I get that question a lot of, hey, are we going to be competing with electrification? We actually think that we can be an enabler for electrification.
You mentioned that you're going after kind of this massive market, $400 billion. 300 is in kind of that car segment, and it takes just forever to enter that space. So even if we focus in on kind of the 100 billion, you've been at this for a good long while with LiquidPiston, and I know there's early investors who have been in for a good while. When you think about kind of timeline to really scaling this up and thinking about exit opportunity, how do you think about that? Where do you see that going?
Yeah, those are great questions. So we are in kind of advanced stages of delivering prototypes to the Army, right? Like advanced prototypes. So what that means is by the end of next year, we want to give the Army both engine and generator prototypes that they can start to qualify for fielding in use. So we're getting a lot closer to a fielded application. My best estimate, and this is just an estimate, would be about 2 to 3 years towards something that can be fielded. And again, our business strategy is to be very kind of targeted and go after initially a low volume, kind of a high price, low volume application, get our footing there. And then we have a strategy to scale rapidly by applying engineering services. We can have relatively small, focused teams enter a lot of markets quickly with a large number of partners and really leverage partnerships to accelerate that adoption. So I think we're well on our way.
And just to take one step back, I'd love for you to explain, some of the processes and things you've had to go through to get here, because commercializing really inventive technology, whether it be in the military or in vehicles and all these things, like we said, is a really slow, really challenging process. So it's not like you're just sitting there, twiddling your thumbs. I know that you guys are investing, working really hard to make this happen. Talk about some of those steps that led to getting 35 of the 65 million you've ever gotten from the military happening within the last few months. What did you have to do to get to this point?
Oh, there's just a tremendous amount of work, and we have really a tremendous team behind us, and the employee team is fantastic, and then we have an army of consultants and contractors that so it's a whole army here that is what's making this happen, and there's a lot that goes on behind the scenes. First of all, we were in pursuit of a new thermodynamic cycle. So talk about a moonshot project initially, right? This was a science project in its early days of, hey, how do we fundamentally change the operation of an engine? And there was a lot of iteration. We went through 4 different cycle architectures before converging on the X engine. And even today, we have a skunkworks department, kind of an internal department that my father leads that is working on stuff that's 5 years out. Right, so we have this constant pipeline of innovation, and we've gotten really good at designing and building and testing things. Now we have a machine shop in-house. We've got 5 full-time machinists and a lot of CNC capability. During COVID, that became a real challenge for us, was getting parts on time from suppliers. So we literally just bit the bullet and had to invest in that. At some point, we foresaw a bottleneck in testing, and we invested in a complete testing infrastructure. And now I'm seeing that again. So we're basically going to be tripling the size of our testing team and department. In the last year, we've been adding a lot of specialists in different fields. So we have 7 PhDs, actually 8 PhDs on the team. We have a PhD in thermal sciences. We have a machine learning PhD. We have a material science PhD. So there's all these different fields that are kind of coming together to make this work. And financing has been a crucial element for us, right? So these DoD contracts, what you see in the news as a $35 million contract, it's probably 2 to 3 years in the making, right? There's a lot of people involved on our side, a lot of people on the government side that are making that happen.
The vehicle segment that we were talking about, just because I feel like probably get one of the best answers you get out there. End of the day, your technology should very much make it way more possible to get very good mileage, per gallon of gas, and help with this whole movement towards using less fossil fuels.
Mm.
So from an outsider's perspective, you go, why would they not want to use a technology like this? Like, I don't get it. Can you talk about some of the reasons why it takes so long? Is it safety driven? Is it OEM supply chain driven? Is it just fear of change? Like, what is it that's preventing the adoption of something like this in that segment?
Yeah, it's a combination of a lot of what you said. We've spoken to almost every car company out there. And by the way, when I say that we're not pursuing automotive, it's really that it's not something that we are like actively pursuing as our number one opportunity. We're still having a lot of conversations out there. We're still under different kinds of agreements with different car companies. The only car company that I really haven't spoke to that I've tried to speak to is Mazda, ironically. They have the Wankel rotary engine, and they say, liquid piston, you're not a Wankel rotary, we don't want to hear it. So they won't even talk to me. But what we find there, unfortunately, is really kind of an NIH, right, not invented here syndrome. And it really wasn't until a player like Tesla came along and shook things up that you start to see any kind of movement in the automotive world. So it's just a challenging, very conservative space to really drive change.
For those who are listening in, who are interested, maybe kind of on the line, the last question I always love to ask here is what's kind of your final pitch to folks of why they might want to invest right now?
Look, this is a new technology that is fundamentally disrupting the internal combustion engine as we know it. It's a technology that it's a field that's ripe for disruption. It's begging for disruption. And as hard as anybody's tried to kill the engine in the past, it's a simple, cheap device that works, and it's really hard to kill. The benefits, the change in this field have been incremental for a very long time. We're offering something that is a step change, right? Like truly disrupting this field. So I think it's an enormous market opportunity. We've got 15,000 investors that have invested over $40 million at this point. So, a lot of folks believe in what we're doing. The government traction is only building with 65 million in contracts. So that there's just a lot of proof points in kind of showing that this is going to work. We appreciate the support of all of our investors, and we couldn't do this without them. So
Thanks so much for listening to the show. If you want to use the same tools I do to find amazing founders like the ones I have on the show to power your investment decisions, you could head on over to kingscrowd.com/startups to try out our Edge Toolkit